Continuing with our discussion on motion along a straight line, let's now take a look at non-uniform acceleration. In the previous video, we covered constant acceleration. For constant acceleration, we had two cases: acceleration constant at zero, uniform motion, and acceleration constant at a non-zero value, you have uniform acceleration. So, uniform motion and uniform acceleration for constant acceleration. If the acceleration is not constant, we have non-uniform acceleration. When the acceleration is not constant, the object is said to be undergoing non-uniform acceleration. For non-uniform acceleration, you go back to the basic definitions of acceleration and velocity. You have acceleration is equal to rate of change of velocity with respect to time. A is equal to dv over dt. On the other hand, for velocity, velocity is rate of change of position with respect to time. V is equal to dx over dt. So these are the two basic definitions. Basic definition for acceleration, basic definition for velocity. And you use these two equations when you have non-uniform acceleration. And depending on the problem, you might have to either differentiate or integrate. Typically, a problem of non-uniform acceleration will provide an equation that is describing the motion of the object. This is one big difference between non-uniform acceleration and uniform acceleration. Both have non-zero acceleration. How do you distinguish a problem of uniform acceleration and a problem of non-uniform acceleration? One indication that you have non-uniform acceleration problem is the problem will provide you with an equation that is describing the motion of the object. And depending on the problem, you might either have to differentiate or integrate the equation provided by the problem, as you will see in the following example. Consider the following sample problem. The position of a toy car is found to be described by the following equation. X is equal to negative 5t cubed plus 4t squared plus 6, and the unit is millimeter. Determine the displacement of the toy car from t is equal to 2 seconds to t is equal to 5 seconds. At the 5-second mark, what is the acceleration of the toy car? So for the first part, as you can see the problem itself provides an equation that describes the motion of the object. In this problem, you are provided an equation for position x. The object moves along and the position of the object is being described by this equation. X is equal to negative 5t cubed plus 4t squared. Some other problems might give you equation for velocity or equation for acceleration. And depending on what is being asked for by the problem, you might either have to differentiate or integrate the equation provided. So let's go to the first part. Letter A, determine the displacement of the toy car from t is equal to 2 seconds to t is equal to 5 seconds. Displacement is change in position. So all you need to do is determine the initial position and the final position of the toy car. Get the change in position, final position minus initial position. That will give you the displacement. The equation provided is in terms of position. So, just plot in initial time into the equation, t is equal to 2 seconds. And you have the initial position, negative 18 millimeters. Then plot in the final time, t is equal to 5 seconds. So this is wrong. This should be 5 seconds. x2 of t is equal to 5 seconds. Final position, plot in 5 seconds into the equation. And you will get the final position to be negative 519 millimeters. Final position, initial position, change in position, displacement is just final minus initial. You get negative 501.000 millimeters. Moving now to the second part of the problem, letter B. What is the acceleration at t is equal to 5 seconds? To be able to determine the acceleration at 5 seconds, you need the equation for acceleration. Going back to the previous slide, basic definition, acceleration is equal to dv over dt. To be able to differentiate velocity, you need the equation for velocity. Velocity is differentiation of x with respect to time. To get the equation for velocity, we differentiate the equation of x. And the equation for x is provided. So we just differentiate this equation with respect to time, dx over dt. We get negative 15t squared plus 8t. Now that we have the equation for velocity, if we now differentiate v with respect to time, we get acceleration. So differentiating negative 15t squared plus 8t, differentiating with respect to time, we get negative 30t plus 8. The equation for acceleration. And now that we have the equation for acceleration, we just plot in the time for t is equal to 5 seconds. The acceleration is negative 142.000 millimeters per second squared. In this particular example, we differentiated the equation twice. Some other problems might require you to integrate the equation twice or once. So depending on the problem, you will either have to differentiate or integrate the equation provided by the problem. And that's it for now. In the next video, we'll continue our discussion on motion along a straight line or kinematics. In the next video, we take a look at free fall motion. So again, that's it for now, and thank you for watching.